My name is Lung Hu. Currently, I'm the professor in the mechanical and electromechanical engineering at National State University. Today, I'm going to briefly introduce what my innovations is for the course of the principles of the machine design. Okay. So first, let me ask you guys a question: that what's the role of the professors in the AI or cyber era? What's our traditional image should be like this, right? So we are a powerful professor, and we are teaching the students just very tightly sitting and listen to what professors teach, right? Okay, so is this what we or our student want, or it's just professors want? Okay, so in this kind of teaching style is the easiest way for us, for professors, right? We can use the same handouts, same slides, same notes, right, for teaching over 10, 20, 30 years. However, my conclusion is that professors are nobody and nothing in the AI era because students can self-learn from the cyber world, and they can get the solutions from any type of AI app, right? So how to activate students' motivation is our job, but not stand in front of them. No, just keep talking. Okay, so I'm going to use two courses. Okay, the principles of the machine design 1 and 2 to introduce what more innovation of these two courses. So first, of course, I'm going to reduce the lecturing time in classroom, of course, and increase the time of the hands-on experience for PBL, the problem-based learning. Okay, and this problem-based learning course, integrates all the courses that the junior student had learned in the department of the mechanical engineering, including the engineering graphic control system, dynamic programming, computer aided design, circuit design, so on. And also, I'm going to provide some discussion, deeply discussion, relate to the industrial case in classroom. Okay, I'm going to introduce this case study later. And these two courses are belonging to EMI, okay, and they're paperless. I never used any paper test or paper assignment in this course. Okay, and also I have recorded my course and upload to YouTube channel for the worldwide students. Of course, if the in-class student, they already registered this course, they can just surf the YouTube and watch the videos anytime they want. And I'm gonna have two robotic contests for their final score, which is the part of their final score, okay, in each semester. For the first semester of this course, I designed the contest of the silicon wafer conveying robot, and for the second semester, I designed the robot context of the sumo robot. Okay, so this is the blueprint of my course. So first, the lecturing course. Okay, so I already mentioned this previously. So my course now is recorded and uploaded to YouTube channel for worldwide students. And also in classroom, I'm gonna provide some industrial case study for those students they can discuss. And for the robotic design, okay, they can use any CAD tool, SolidWorks, AutoCAD, Inventors, and so on, okay, to design the silicon wafer robot or the sumo robot. Okay, and the homework, assignment, exams, they're all paperless. They can upload their PDF file after graded. I'm gonna reload it again. Okay. So for the final exam, or we'll say the final scores, they have to fabricate from their design by using those CAD tool. Okay. So this the contest, integrate those cores that student had learned, right? I already mentioned previously. Okay, so this one case of the case study. Okay, for example, I'm gonna provide this kind of industrial problem. So there are two types of car brand. One is the Volvo, and the other is the Toyota. If you are a driver, so which one you will buy? And from your personal perspective, which one is safer? Of course, from the stereotype, we think the Volvo is more stronger than that of Toyota, right? However, if we utilize the straight energy point of view, well, I think maybe the both drivers are safe because the car frame or the structure of the Toyota has the highest strength energy. That's mean it has the higher resilience. That's mean they have the more capability to absorb the deformation, right? Even though the car is being crashed, however, the driver and the passengers are safe. Well, anyway, I'm just gonna mention they can use the different thinking, you can think of the outside the box, right? So we have a different perspective, and I will not give the correct answer. Okay, you can just provide any diverse perspective in this case study. Okay, so this is one example of my student who designed this robot. Okay, this robot by a CAD tool. Okay, and also what I mentioned, the paperless EMI course, right? So student will upload their report or the assignment or homework, and after graded, I'll just re-upload it. Okay, so they can just check their score, right? Okay, so this is the robotic contest. Okay, so basically we have the 2-inch wafer shelf case. Okay, so the robot will just convey this 2-inch wafer from the starting point to the end point. Okay, this is about the 150 centimeter, and in 5 minutes. So how the highest number of the silicon wafer conveyed it in 5 minutes will get the champion. Of course, the champion and the second and the third place will have to know kind of the different final scores. Okay, and the second contest, robotic contest, is the sumo. Okay, so it's quite easy. So team 1, 2 teams, right? And if this one robot is pushed out outside the boundary, okay, outside the boundary, so it can lose. Okay, it can lose. And also, I encourage students to join some, robotic contest held by different companies. Okay, so next I'm gonna introduce some videos about what the EMI course that I recorded and uploaded. And next is the silicon wafer converting robot. Okay, I also upload to the YouTube channel and also the sumo robotic contest. Okay. Okay, and those challenges and adjustment of this course, these two courses can be, I think these two courses can play the role of the connection between the industry and the academy, right? And most of the students from the general high school, they cannot, understand what this industry really needs, right? So hopefully I can just build up this course and to be a connection, okay, between the industry and the academy. And the second importance, or we say some difficulty, is the fair and the practical evaluation system. Why? Because most of the students, I don't know why, but the current students, they really care about their score and they really care about the fairness. However, from the design point of view, professors or teachers cannot evaluate your product. And who can evaluate it? The customers, the buyers, the users, right? The users can evaluate your product, your robot, right? So well, I'm still trying to design the quite fairness evaluation system, okay, for those students, to make them feel it's fair enough, okay. And the other, I think the most difficult challenge is it's quite tough to expand it. It's kind of the teacher style to the whole department, cross departments, or the whole the school of the engineering, right? So as what I mentioned in the very beginning, I mean the teaching style, just standing in front of those students and keep talking, keep talking. This kind of teaching style is the easy way, right? So if you ask those professors or teachers to, modify themselves, they have to prepare, a lot of the, we say the materials, right? So those, 10 years, 20 years, 30 years handouts, if you ask them to throw out those old school handouts, I think it's quite tough. It's quite difficult for them. Okay, but anyway, I think we are gonna work together and try to modify and try to make this teaching environment to be better. Okay, and to be more practical, to be more the PBL base, right? So yeah, so that's my introduction of the innovation, of these two courses. Thank you.